Hi, this video is for the Unit 1.1 and 1.2 vocab quiz. So you all took the vocab quiz the first time, and I told you to take it without notes so I can review the data and sort of see the things that we know and don't know. And I'm going to go over the 4 questions that we had the lowest results on. Part of it, I think, may be because people are misreading the question or not understanding what the question is asking. So I definitely want to address that to make sure that when you take it again, you know what to look out for. And then some other things just have to do with the language. So the first question I want to look at is question, for me it's question number 1, but the orders will change. But it's the one with octasulfur is a yellow solid with a chemical formula S8. Which of the following terms best defines the substance S8? And it says select all that apply. So whenever you see select all that apply, that means that there could be more than one answer. Not always, but there could be and likely will be more than one answer. So we have the chemical S8, and the choices we have are molecule, atom, element, and compound. The thing you want to be careful about with this, if it's a select all that apply, that means that this could apply to different things. So let's sort of break down how we classify matter. So when we talk about classifying matter, remember all matter is made of atoms, and the atoms, if they connect or bind together with chemical bonds, they form molecules. So a molecule is anything that is made up of 2 or more atoms. So if you take a look at what we have here, we have these that are grouped together in the red box. These are all molecules. As you can see, there are 2 or more atoms that are connected together. And these are actually relatively small molecules. There are molecules that are huge, that have a lot more than just 2 or 3 atoms. Helium, on the other hand, is out by itself because it's not a molecule, it's just a single atom. Now, let's go into the definition of an element versus a compound. An element is any substance made up of one type of atom. So both helium, which is what you put in helium balloons, and oxygen, which is the oxygen that we breathe, they're both elements because, as you can see, if you had a sample of helium, even though the atoms are not connected together with chemical bonds, they are still elements because there's only one type of atom inside that helium balloon. And oxygen, the oxygen atoms that are connected together are the same type of atom, so it's an element of oxygen. So elements just have one type of atom. Where compounds can have 2 or more types. 2 or more different types. So water, for example, is made up of hydrogen atoms and oxygen atoms. They're not the same thing, so you have different atoms here. And sodium chloride, which is table salt, is made up of sodium and chlorine atoms. Now again, compounds can be much more complex than this, can have more than just 2 types of atoms. They could have 10, 20 types, whatever. Very rarely do they have 10 or 20 types, but you can have molecules with a variety of atoms, different types of atoms, and they're called compounds. So as you can see here, the classification for molecule just means if you have 2 or more atoms, it's a molecule. In order for it to be an element, it has to have one type, and in order for it to be a compound, it has to have 2 or more type of atoms. So something can be both a molecule and a compound, both a molecule and an element. You can also have something that is an atom, like helium is, and an element as well. So if you go back to that quiz, you can see here you have S8. So how many atoms do you have? Are they the same type of atoms? Are they different types? And you can use that to help you answer that question. The next question to go over is in this video where you watched a video of sodium metal reacting with water, and when you play that video, you'll see that there is a change happening. And the question is it a chemical or a physical property that we're observing? Now, when we talk about a chemical or a physical property, whenever you see the word chemical, whether it's in front of a chemical change or a chemical property, the substance itself, the identity of the substance changes. Okay? So that means whatever you start off with, you're not going to have in the end. When it comes down to a chemical change, you're observing a change where the substance becomes something else. And if it's a chemical if it's a chemical property, that means that the only way you can observe it is when the substance change. An example of a chemical property is toxicity. The only way you can observe the toxicity is if somebody consumes or something consumes that toxin and their body metabolizes it, and it results in the person getting ill or dying. In doing that, in the body metabolizing that toxin is no longer the same thing. So the only way you can observe the toxicity of that chemical is by that chemical changing through it being metabolized. Whenever you see the word physical, whether it's a physical change or a physical property, there is no change. So when I like to think about physical, I like to think about somebody bending an iron bar or something like that. You're doing something very physical there. You're bending that bar, but you're not changing the fact that it's still iron. So when it comes down to a physical change, it's a change that does not result in changing the identity of the substance. You may change its form from a solid to a liquid, for example, so that you can change the state it's in, but you're not changing the identity of the substance. And a physical property is a property that you can observe without changing it. For example, you can look at the color of something and you're not changing it. In order to see the color of it, you don't need to change that substance. So whenever you see physical, no changing in the substance, no changing the identity of the substance. Chemical changes the identity. The next thing I want to go over is this matching problem. So there's a note here for this matching problem where you're asked to match the description of the to the correct subatomic particle. It says, note, one description is not unique and therefore cannot be matched to just one subatomic particle. This description will be an extra description. So what I mean by that is there's a description that can apply to, let's say, both an electron and a proton. And so because it can apply to both of them, you can't just put it at one, you can't use it. All right, notice that there are 4 descriptions here, but only 3 spaces. Well, one of those descriptions it's not going to work for just one. So an example of that would be, for example, if it said a subatomic particle located in the nucleus. Well, that will apply to both a proton and a neutron. So you wouldn't be able to use it because that's not unique to just one subatomic particle. However, if it said a subatomic particle located in the electron cloud, well, the only one that's located in the electron cloud is the electron, or the electron, so you can match it to electron. Okay? So you want to make sure that whatever you're choosing can only apply to proton, can only apply to neutron, and can only apply to electron. If it can apply to something else, then you don't want to use that one, even if the statement is true. Okay, the last one I want to go over is the one about the isotopes of rhodium. So remember, isotopes have the same same atomic number because they have the same number of protons, which means they're the same element. Number of protons equals the atomic number, which identifies the type of element. So if you have the same number of protons, i.e. the same atomic number, you're the same element. So that bottom number, the atomic number, stays the same. The top number, the mass number, changes because isotopes, they're the same element, but they have different number of neutrons. Because you can change the number of neutrons in an atom, and you're not going to change the identity of the atom. So with that being said, when you are looking for isotopes, you only want to focus on mass number and atomic number, looking for the top number to be different, the bottom number to be the same. You don't need charge when it comes to isotopes. Doesn't matter what the charge is, they can still be isotopes whether they have a charge or not. So as long as their mass number is different, the top number is different, and the atomic number, the bottom number is the same. All right, so those are the questions that we had the most difficulty on. So if you haven't done so already, and you ought to, you want to improve your learning and improve your grade, please retake that vocab quiz, which you can find in your Unit 1. So it's in the Unit 1, Week 2, Tuesday folder, or alternatively, you can find it from your gradebook. All right, hope you found this video helpful. Have a quality day.